Hello. Today I'd like to talk to you about mega-constellations of satellites and the problems that they can cause. But first of all, let me give you a bit of background. So in the last couple of years, there have been two major revolutions in the space industry. Both of them, interestingly enough, involving Elon Musk, who's been a pioneer in several fields. The first is the development of a reusable space launcher, or rocket, as we amateurs call them. Elon Musk's company SpaceX has developed a launcher which goes up, comes back down and lands and can be reused. Whereas for the last 50, 60 years, rockets have been one use. They go up, they don't come down. They usually burn up in orbit in the atmosphere as they re-enter the Earth's atmosphere. The fact that a launcher is reusable means that it's cheaper and that satellites can be launched for less money. The other big revolution is the mega-constellation. As the name suggests, a mega-constellation of satellites is one that has an awful lot of satellites in it. Just to give you an idea of the order of magnitude, there are currently 6,000 satellites in orbit in total. So all companies and all countries put together have 6,000 satellites in orbit. 1,000 of those satellites are Starlink satellites of Elon Musk's company. But when the Starlink constellation is complete, it alone will have 12,000 satellites. And Starlink is just one of half a dozen potential mega constellations that are being proposed or planned or already launched. So you can see that the order of magnitude has changed completely. Let me just tell you quickly how communications satellites have traditionally worked, so you can understand what I called a revolution a bit better. So a traditional communications satellite would be sent up to what's called geostationary orbit at 35,000 kilometers above the Earth, where it is literally parked. As the name suggests, it's not moving, it's geostationary, it's always over the same part of the Earth, and it transmits to that same part of the Earth. This is the sort of thing that your satellite dish will capture for your TV, but all sorts of other communications use this as well. There are other orbits around the Earth, however, and one of those is the low Earth orbit, which, as the name suggests, is much closer to Earth, just about 100 kilometers. And these orbits are not stationary. In fact, the satellites go round very, very quickly. And these satellites have traditionally been used for example, for taking photographs, either environmental observation, oceanic observation, or spying, quite simply. I think you've all probably seen a film, a spy film or a military film, where somebody has said, hold on, the satellite won't be overhead for another hour. And that is exactly this satellite that goes overhead, over the horizon, and around the Earth again, and comes back again in a few hours' time. But because of that motion, because of the fact that the satellite is not over the same part of the Earth for any great length of time, they haven't been very good for communications. At least not until now, when somebody had the idea of filling the sky with them. If you have enough of these satellites in low Earth orbit, then as one passes over a piece of the Earth and moves away from it, another one comes in behind and picks up the transmission to that part of the Earth. And as that one moves away, another one moves in behind it and picks up. So there's always a satellite overhead transmitting for you. Now, what's the advantage of that? Well, mega constellations are in, as I said, lower Earth orbit. That's nearer, so it's cheaper to get to. I've mentioned that we have these reusable launchers. The fact that the satellites are in lower Earth orbit also means they can be smaller. All of these things make them cheaper. And cost is the principal advantage of the mega constellation. If something's cheaper, you can sell more products on the basis of it. And cheaper also means access and affordability for more people. And the big selling point of the mega constellation is global internet to remote areas like Africa and India, where cabled internet connections are simply not a realistic option. The distances are just huge, and the infrastructure is just too far behind to start with. Another big advantage of the lower Earth orbit is that there's less time lag. Even at the speed of light, a radio signal will take 4 seconds to get to a geostationary satellite at 35,000 kilometers away and back. And that, in an age when we're all talking to each other on the internet, makes for horrible delay. A conversation with a 4-second lag is extremely difficult. So the mega constellations will solve that problem. However, this all comes at a cost. Thousands and thousands of satellites in the sky means thousands of pieces of potential space debris, rubbish, junk flying around in the sky, which could crash into other satellites and create more debris. This issue of space debris has been a problem for many years, and it's only going to get worse with the mega constellations. But the real problem, and the one I want to focus on today, is astronomy. We've been watching the stars for thousands of years, and the Earth-based telescopes that we have, the European Southern Observatory, for example, in Chile, have been responsible for some great scientific discoveries. Confirmation of Einstein's theory of relativity, discovery of a planet in the habitable zone around our nearest neighbouring star, Proxima Centauri, and many, many others besides. But all of this science will be impossible, or similar science in the future will be impossible, if we can't see the stars because of reflected light from satellites. And that's the big problem for astronomers. Satellites reflect the sun's light, which is brighter than the stars the telescopes are looking at, and so astronomers can't see those stars. And just to underline how serious this issue is, I wanted to read to you from a statement made by the American Astronomical Society, which you'll find on page 3 of the document that I handed out earlier today. It's the third paragraph, indented slightly more. The American Astronomical Society notes with concern the impending deployment of large constellations of satellites into Earth orbit. The number of such satellites is projected to grow into the tens of thousands over the next several years, creating the potential for substantial adverse impacts to ground and space-based astronomy. These impacts could include significant disruption of optical and near-infrared observations, where satellites pass through a telescope's field of view. The AAA recognizes that outer space is an increasingly available resource with many possible uses. However, the potential for multiple large satellite constellations to adversely affect both each other and the study of the cosmos is becoming increasingly apparent, both in low Earth orbit and beyond. The AAS is actively working to assess the impacts on astronomy of large satellite constellations before their numbers rise further. Only with thorough and quantitative understanding can we properly assess the risks and identify the appropriate mitigating actions. The AAS desires that this be a collaborative effort among its members, other scientific societies, and other space stakeholders, including private companies. The AAS will support and facilitate the work by relevant parties to understand fully and minimize the impact of large satellite constellations on ground and space-based astronomy. End of quote. So I think you can see that this is an issue of great concern, and I would just like to wrap up now by calling on you to lobby for a limit on the number of satellites that can be put up in any one mega constellation, and also to lobby for an obligation on anyone launching satellites to ensure that their satellite is safely removed from space at the end of its useful lifetime. Thank you.